Welcome to another session of Raz-Lee Education. This is a webinar about zero trust and encryption for IBM. My name is Moshe Sofer, Marketing Manager. This webinar is about to last 30 minutes. So the first thing that we will talk about is about zero trust. Explain the concept behind the so much used word right now, and how encryption can help you to start your zero trust journey. It is really important to differentiate what really zero trust means, and there is no way that you can achieve a zero trust without having the corresponding policies at your company. So let's start. Zero trust is an architecture and has become one of the most used buzzwords. But what's the real meaning behind it? There is a concept that is really powerful and is never trust, always verify. So if we think about never trust, it means that we have to make constant security checks. So we have to use granularity security. Really be conscious of the person doing an action is able to do that action. So we will verify every time that we have to make a change in the system. Why we should move to a zero trust approach? Okay, first, zero trust is based that traditional security models are in the assumption that everything inside an organization should be implicitly trusted. Normal security, IT security, is about the perimeter, the limits, and the sign-on. And after you get into the system, we assume that you're in a safe environment. You're in a safe place. Okay, that's not so true. Why not? Because probably someone inside that environment will activate a virus without even knowing it. Someone inside that environment has the potential to make permanent damage to data because has super high authority. Or maybe someone inside that environment, it's a hacker that is using someone else's credentials. So that's why we move to a zero trust approach. We can understand the model in a better way if we think about zero trust on 5 levels: devices, data, networks, workload, and people. So these 5 levels, I will explain it in detail to understand each one of those. With that, we will be able to really understand what is a zero trust approach. Zero trust device. Okay, it's talk about every device that is connected and mapped to the network should be able to be safe. Probably you have worked with a server and a PC, some printers, maybe a scanner, another network PC, or a network with several PCs. And then you have tablets, and then you have your cell phone that also has an email and also has the Google Drive for the company. And you have access to all the server from your PC, from the server directly, from your phone, or from your table. So all these connected devices really has vulnerabilities because you are entering to a network from outside and you leave the door open. This is the case for an FTP connection. Or maybe you are entering from one device without a VPN and you have opened an ODBC connection. So the device must be secure and controlled. That means that we have to know which devices are allowed to enter the network. About the data, we need to know exactly what data we have in our server. And this includes securing and managed data and includes the encryption of data in transit and at rest. Okay, data in transit is when you are moving data from one computer to another or from one network to another. So you have to be sure that this data in transit it's encrypted. But also you have to be sure that your data at rest, in example, your files, your databases, your records are also encrypted. The network. Okay, the ability to segment a network or isolate something in the network and control the communication inside the network. This is quite critical. Why? Because you cannot have a zero trust architecture if you don't use a firewall. So the first step is to know your device. The second step is to make encryption. The third step is to use a firewall. But for IBM I, this is different because you need a firewall that specifically works in IBM I. And we will talk about this on the next week. There's a chapter of Raz-Lee education called Zero Trust and Exit Points. So don't miss it because it's really important how to protect your network. The workload, it's a little more complex. And here you need really a good management of architecture because it means the security on the front to back application stacks. So the front to back application stack has to be with high availability and they have to be working, but not at the maximum, because if they are working to the max, you will lose the process and you will not be able to make security checks for performance reasons. So tomorrow we will talk specifically about how to survive a combined attack, but in some point of the tomorrow intercourse, we will talk about how to lower the resource needed to make security checks using ICAP clients for the antivirus. So it's really important. If you want to know what are the advantages of an ICAP client with an antivirus and how to release workload from your server, tomorrow we will explain that in detail. And then we have the concept of people. So in this case, we have to be sure that people are the ones who they say they are. Also, we have to be sure that they have the privilege to do the actions that they are doing. But in a zero trust approach, all the people has to have the lowest privilege possible. And then when they need more privilege, they should have those privilege temporarily. So we will talk about this in another course during next week also, because this is something related to authorities on the IBM I. So you have to have control of the authorities. There is a good way to do it. There is the authority investigator, and you can have every user with the authorities they have and why they have it. So, as a summary, this zero trust model approach can be divided into devices, data, networks, workload, and people. So we will continue. The encryption and zero trust. Why are they related? They are related in the data aspect because we told we need the data encrypted in transit and we need the data encrypted at rest. But moving the data in transit also is network because the network has to be secure. So if you can see on the left, we have everything related to the network that is already in red and an intrusion prevention system that is related to the users. And in blue, we have the data leak prevention and we have the database encryption. So we will talk specifically about that, how encryption can help you to start your journey to zero trust. Because the first item, that is devices, we already know what devices are able to enter our network. So step one, we will prevent data leaks. The first step, it's the most critical and valuable data. Where is the most critical and valuable data? Sometimes play with the permissions, who can enter to see the data, or who is allowed to manipulate the data. It's enough, but it's not the best. And in the end, it's not enough because you could have your data encrypted and masked. So anyone who enters can see or no data or a masked data, or if he truly is able to see the data, he will see the data as it is. And the second step is secure the data in transit. So when I'm transferring files between devices, the risk is multiplied. And the unauthorized entities know this because they are using external devices connected to another device and connected to another one. So the risk is multiplied as many times. So the files must be encrypted from source to target. And this can be done inside the IBM. So we need to make sure that if we are talking about making our company moving to a zero trust architecture, we're also moving the IBM to a zero trust architecture by his own. So what we need encryption tools, and we need only 2 tools to make all the job. The first tool that we will use is the Field Encryption. It's based on the file proc. So file encryption is native encryption and tokenization. What's the best about this? That is encryption and also tokenization. So we have 2 ways to make our data secure. So first of all, encryption will show the data in a different way that suits the user. Before I was talking about maybe it's better to show some users no data or masked data or full access to the data. And that can be done with encryption. So we have clear text, masked, scrambled, or no text. And this also gives us compliance with PCI DSS, HIPAA, and GDPR and other regulatory bodies. They require encrypting sensitive parts of the data. So with the field encryption, we can make this typical encryption of credit card number, passwords, and sensitive information that will be encrypted and will be showed only as a masked data. So the data at rest and the key management. For example, we can use transparent encryption, or we can encrypt a database. We can also do application data protection. We can do tokenization. We need an enterprise key manager, and probably we will need a cloud key manager if we are talking about using a zero trust environment and we are at the same time using a cloud environment. So in any way, we can do all these tasks. Also, encryption has a counterpart that is called tokenization. And they are quite different because encryption is a mathematical process. In encryption, the length of the fields change and they are shown as blocks of information. But in tokenization, it's a different approach. It replaces sensitive data with no sensitive substance. So the type of the field and the length of the data still the same. And this is really important because it's a way that you can render the information and you make the information unreadable. So there is a little problem with normal encryption that probably after the encryption, some middleware will not understand the data. With tokenization, they will still understand the data and the kind of data that is shown. As you can see in the picture, we have the original data and we have the token data. So the token data is made with different kind of tokens and they, through an algorithm, change the information and then they can reverse this change. Identically to the encryption in the way of working, but it's non-mathematical approach, is a sensitive data approach. What about the encryption keys? Okay, the encryption keys are always something that you have to think about it. In the case of the iSecurity Field Encryption, we have a local master key. And this local master key will protect the organization key. The organization key protects the key encryption key, or CAC. And the CAC is used to protect the data key. The data key encrypts data. So first, we have the organization key that is enters on each helper. And the master key, the CAC, and the data keys can be periodically modified. And this is really important. They can be periodically modified, and you should periodically modify them. Because if in any case someone has access to these keys, he will not be able to use them anymore when you change them. Okay? But to be sure of that, there's no way to see or access the key value. So being ensured that we are protecting our systems with all this key structure, we have compliance with the zero trust architecture about protecting data at rest. Now we need to protect the data in transit. So we will use the iSecurity PGP encryption. This encrypts, transfers, and decrypts. As simple as that. So First, encrypts IBM files using the public encryption. The best way to do it is using a combination of encryption, such as hashing or data compression or symmetric cryptography. And then you have public keys. And the public keys keep the data secure because you can encrypt your data, transfer it, and then in another network, totally different, in another part of the world, they will decrypt the files and get them back. So iSecurity PGP encryption supports multiple encryption algorithms, which is really good, includes AAS and TDES. And the correct private key can be decrypted and open the protected files. Only the correct private key. So it's built it to support multi-site, multi-helper organizations. So we don't have to worry if you have a multi-helper organization, it will work anyway because it's built for that. And the key management capabilities are enabling you to create important export keys and also to encrypt or decrypt files. So you have all range of tools that you need to work. Also, there is a special set of commands that you will have when you get the product, or if you want to see later on the website, you can see that you have many special commands to work on the green screen, and you can do all the tasks that you need using commands. The implementation provides all the commands that you need. Here is explicated because it's also able to identify fingerprints, not only creating encryption and decryption, but keeping the key, modify them, and put new pair of keys. The idea behind all of this is that you can encrypt, send, and decrypt every kind of file. And this includes native files, and this includes IFS files or directories. So what's the big deal? You're not just encrypting or decrypting like in a Windows server or like in a Linux server. You're working specifically with encryption and decryption for the IBM objects. So as a summary, how encryption helps on zero trust. First, helps to protect sensitive IBM data. Second, secures the mail communication because you can set that everything that is sent through a mail will be automatically encrypted before sending it. Third, supports the regulatory compliance requirements. Of course it does, because compliance is really important for us as Raz-Lee. So every product and solution is helping to your compliance. And then fourth, prevent the need of manual process to first transfer files to a PC and then encrypt them. So you don't need to manually transfer the file, encrypt it, transfer it, and then decrypt it. It will do it automatically. And this is really helpful because you don't need to remember how to do it. You will set it on the beginning to do it automatically. Then 5, and nevertheless important, ensures real end-to-end encryption transmissions. So this is what the first point was. Move the data in transit encrypted. So as is end-to-end transmissions, it refers that we will comply with the network and data transmission part that is on zero trust. It is really important to remember that any company that is entering to the zero trust approach and they want to implement it, it could take several months because you need also the policies that validate the usability of the software. And you need to make a long process to get from non-zero trust to zero trust. But the process could be shortened in a great way when you use the right tools. So I invite you to write your questions. If you have it, you can write your questions now and I will answer them. So if you are looking to this video later on our YouTube channel and you have some questions, you can write them in the comment section. So first question is, if there is an important change in the size of the fields when you encrypt them. Yes, it is. It depends on the way that you're encrypting them, but usually the final size is larger. So you need to have a hard disk consideration for that. And second, PGP encryption and firewall. Yes, you can use PGP encryption and the firewall, and you have a special rule on the firewall to open the communication with the PGP encryption. And in the case of iSecurity firewall, they work together, so there is no conflict. And in the case of another firewall, there will be no conflict also because you're just transmitting data, and the data what actually was automatically encrypted before and is sent, and the key is sent also. So you don't have any problems with that. So I'm very glad that you were here today.